start section 10.3, polar coordinates. In polar coordinates, you're going to have an origin or a point O that is known as the pole. So we still call it the origin, just like in the rectangular coordinate plane. We have a polar axis, which is the initial positive x-axis. If you think back to your trig days, you had your initial ray and your terminal ray, or we call sides of your angle. So our coordinates will be r for the radius, the distance from O to P, and theta will be the angle made from your polar axis to that line segment for OP. So that's going to be our polar coordinates. Again, r is the directed distance from O to P. Theta is the directed angle from the polar axis to OP. Counterclockwise is positive. Clockwise will be negative, just like it was for trigonometry. There are multiple representations for the same point r theta. If you have r comma theta plus 2n pi, this is where you get to add or subtract 2 pi, which is just one revolution around the circle. Now you notice I said plus or minus, but you don't see the plus or minus symbol here because n represents any integer and your n could be negative, and that would get you your minus 2 pi if n was a negative 1. You can also switch these polar coordinates. If you want to make the r negative, then you're going to take your theta and you're going to add 2n plus 1 pi, which means you're adding 1 pi. This represents an odd. So this is always theta plus or minus an even pi. This is theta plus or minus an odd pi. So again, you could add pi, subtract pi, add 3 pi, subtract 3 pi. It will still get you the same location. So if you're adding even pi, you keep r the same. If you make r negative, then you better be adding or subtracting an odd pi. So for example, if we looked at the point 1 comma 5 pi over 4. So we can write this in different ways. If I start off, here's my positive x-axis, my polar axis. Here's 5 pi over 4. Basically, it's a 45-degree angle in quadrant 3 in your rectangle coordinate system. So that's 225 degrees if you wanted to convert it to degrees. So if we wanted to, we could think about, let's subtract 2 pi. So I go here and I go 2 pi in a clockwise direction, which would be subtracting 2 pi or adding a negative 2 pi. And that would get me to 1 comma negative 3 pi over 4. I'm just measuring from here and going in a negative distance, or excuse me, negative direction. Or we could take our original and just add 2 pi, make another complete revolution around your circle to get to 13 pi over 4. 2 pi would be 8 pi over 4, and 5 pi over 4 plus 8 pi over 4 would be that 13 pi over 4. All right, now let's make the r negative. So if r is going to be a negative 1, we need to subtract 1 pi or add 1 pi to this, which would be 4 pi over 4. So I opted to subtract 4 pi over 4 from my theta, made my r a negative 1, and I'm at now pi over 4. All right, plotting points. So if we wanted to plot A, and then we're going to find 2 other pairs of quadrants. So we'll do a plus 2 pi, and maybe we'll look at a minus 2 pi or make the r negative. Whatever we want to do. It's wide open. So we go to 4 on the polar axis. There's our 4. Now I'm going to travel a negative 7 pi over 6. So I'm not going to go counterclockwise. I'm going to go clockwise. All right, pi over 6 is 2 lines. So it's going to be 1, 2, 3, 4, 5, 6. I would end up at, in essence, another way I could say this is 4, and I can go in a counterclockwise direction to 5 pi over 6. All right, now, if we wanted to make it a negative 4, so we could take this point, make it negative, and subtract 6 pi over 6. That's 1 pi. That would make it a negative pi over 6. So here I would go 1, 2, 3, 4 to the left. There's negative 4. And now I just go a negative pi over 6 in the clockwise direction. So I can think about saying, oh, I subtracted pi from this one, or I added pi to that one. Either one will work. All right. B, 3 comma pi over 3. We'll go to the 3, and we'll go up to pi over 3, which is right there at 60 degrees. So again, we could take and add 2 pi to this, or we could subtract 2 pi. If I subtracted 2 pi, I'll be at negative 5 pi over 3. So pi over 3, 2 pi would be 6 pi over 3. Pi over 3 minus 6 pi over 3, negative 5 pi over 3. If we want to make the r negative, then subtract pi over 3 or add pi over 3 to either one of these two. So I opted to subtract 3 pi over 3 to pi over 3 to get a negative 2 pi over 3. Or if you want, I could have said, well, we added pi to negative 5 pi over 3 to get to negative 2 pi over 3. All right, coordinate conversions. R comma theta, polar coordinates to our regular rectangular coordinates. Here's what we have to know. We have to know that in our right triangle, our x, our y, horizontal, vertical, that's a point we usually given. Here's my theta, there's going to be my radius, and my hypotenuse. X is equal to r times cosine theta. Well, where does that come from? Well, if I look at theta and my r and my x, that's cosine. That would be like cosine theta equals x over r. Sine of theta is y over r, opposite over hypotenuse. Okay, just solve for x and y. Multiply the r's over. R squared equals x squared plus y squared. I believe that's self-explanatory. There's your Pythagorean theorem. And tangent theta, we can't leave tangent out. Tangent theta is y over x. All right, so now if you look at these two, this is when you want to take rectangular and go to polar. And here's if I have r squared theta and tangent theta, if I'm given r and theta, then I can go to x squared and y squared. Okay, so just be conscious of what you're given and where you want to go with it. So let's say I have r theta is 3 comma pi over 4. We're going to turn this into rectangular form. I'm given r and I'm given theta. I need to find x and y. Okay, here we go. X equals r cosine theta. Let's go find x. I'm given r and I'm given theta. R sine theta. We can go find y. So this is great from going from polar to rectangular because that's what the x and the y's are equal to. So 3 cosine pi over 4, sine pi over 4, we remember that's your 45 degrees, that's your square root of 2 over 2. So that would be the rectangular coordinates, come back here mouse, 3 radical 2 over 2, comma 3 radical 2 over 2. Alright, here we have polar coordinates, r theta is 2 for the radius, pi for the theta, again, x equals r cosine theta, y equals r sine theta. Put the 2 in for the r's, put pi in for the theta. Now, pi all the way around, that means cosine of pi is a negative 1, sine of pi is a 0. So negative 1 times 2 for the x is negative 2, 0 times 2 is 0, that's your y coordinate. Example 4, now we have rectangular coordinates. Negative 1, 1, x and y, negative 1, 1. All right, now we're going to be working with this. So first thing I have to understand is what quadrant I'm in. So negative 1, 1, I'm over here in quadrant 2. The reason that's important is because when we try to find our theta, we got to make sure we put it in the right quadrant. Because I know what's going to happen is you're going to go to tangent theta is going to be y, 1 over x, negative 1. And you're probably going to go to your calculator and type in the inverse tangent of negative 1. It gives you negative 45 degrees, which puts you down in quadrant 4, but we want to be in quadrant 2. So you have to add pi, or 180 degrees, to get there. So that puts me at 135 degrees, or 3 pi over 4 for my theta. So in polar coordinates, you can work in both radians and degrees. Predominantly, it's mostly radians, but you can always convert them into degrees if that helps you with your angle recognition. Now, there's my theta. Now we got to go find r. What's the radius? Okay, well, think of your triangle here, Pythagorean theorem. x squared plus y squared. Okay, 1 squared plus 1 squared. Doesn't matter if the 1's positive or negative. It's going to be a 1. 1 plus 1 is 2, so my radius is square root of 2, and my theta is 3 pi over 4. There's my polar coordinates. So if you want to go from polar to rectangular, you use x equals r cosine theta, y equals r sine theta. If I want to go from rectangular to polar, you use tangent of theta equals y over x, and your Pythagorean theorem, r squared equals x squared plus y squared. Always double check. Plot the point, the rectangular, plot it so you know what quadrant you're in to set up your theta. Polar curves. We can graph polar equations by plotting some points r theta. We can plot them in our graphing calculator, or converting the polar equations to rectangular Cartesian equations. Okay, so for example, some of these will jump out at you. Some of them you might want to go look at them in the calculator just to make sure that it actually works. And I'll bring up my calculator here and we'll do that. R equals 4. The radius equals 4. We're going to do this in a blue line. So any radius is 4. Notice that there's no theta here. I can have any theta I want. Okay, that would be a circle. Oh wait, my equation of a circle with the center at the origin would be x squared plus y squared equals 4 squared, which is 16. So 1, 2, 3, 4, 1, 2, 3, 4. I can graph my circle in a rectangular plane. Theta is equal to 3 pi over 4. There's no radius here, so I go to 3 pi over 4. Okay, that's this line right here, 135 degrees. I can have any radius I want. Okay, that's this slanted line right here. We'll do this in red. Okay, well that's a linear line. It looks like it has a slope of -1. So to convert that, we would say tangent of theta is equal to tangent of 3 pi over 4. All right, take out tangent theta. Put that in as y over x. And tangent of 3 pi over 4 is a -1. Type it in the calculator. All right, multiply the x over to the -1. Y equals -1x or negative x. Okay, y-intercept of 0, slope down 1, right 1, down 1, right 1. There's the exact same line. Okay, this one, r equals -2 secant theta. All right, let me go grab my calculator here. Well, here's parametric. I've got to go to polar here. So mode, let's go down and highlight polar. Then we'll go second quit back. So I got something already in here. So here's my polar coordinates. R is my equation. It has to equal something. Okay, so I have to equal a -2 secant theta. Well, I don't have secant. Secant is 1 over cosine, so I can multiply this by 1 divided by cosine theta. And then I can graph it. Oh, looks like we're going to get a vertical line here. Now, because I did use a trig function, I'd have to go to the zoom window. Make sure you hit the zoom 7 to get your trig window. Yep, and then if you look at your window, everything's measured in your radians. So looks like we are graphing a vertical line. Now it's kind of tough to see exactly what's the x value here. But if we go back to zoom 6, our standard window, it looks like we're at x equals a -2. So that's what I'm looking to get here. All right. Whoops, let me get my calculator back over here. Again, zoom 7. All right, test some values, trace. All right, x is -2, y is 0, trying to find some more values on my graph here. Notice my thetas, no matter what they are, they're always giving me x equals a -2. All the way around the circle. Okay? So by hand, change this to -2 over cosine theta, and I can test some easy thetas here, for example. At 0, I know cosine of 0 is 1, so negative 2 over 1 is negative 2. So that's this point, negative 2, 0. If I try pi over 3, I know at pi over 3, that's going to be like the cosine of 60 degrees. That's going to be 1/2. So negative 2 divided by 1/2 is negative 4. So if I go to negative 4, 1, 2, 3, 4, and I go to a negative pi over 3, that puts me right there. Oops, I went the other way. Pi over 3 goes in a counterclockwise direction, then I did the clockwise. There's my 3 points showing me that this is x equals negative 2. Now how do I convert this equation? Multiply cosine theta over to the r to get r cosine theta, which earlier we saw r cosine theta is the same as x equals negative 2. And there's my vertical line. All right, r equals 5 cosine theta, convert to a rectangular equation. So if we were to take this, I'm going to take my cosine theta, and that's x over r. And let's see, we're in polar. We're trying to get to rectangular, so I'm going to multiply this r over to the other side. Gives me r squared. Oh, that's good. Remember, r squared is equal to x squared plus y squared. And so now, technically, this is a rectangular equation. You could theoretically stop right here because you got everything in terms of x and y. Now, however, what does my equation look like? I'm on a graph, if you will, in a rectangular form. So since I have x squared and y squared, I'm thinking this is a circle. So I subtract the 5x over, and then I have to complete the square of the x term. So I take half of a negative 5, negative 5 halves, I square it, and that's what I'm adding to both sides, if you will. And this becomes x minus 5 halves squared plus y squared equals 25 over 4. Okay, well, this is a circle. It centers at 5 halves, comma 0, with a radius of 5 halves. So if we go over here, 5 halves, comma 0, yep. If I went and I started plotting this, and again, I would go to my calculator to start plotting some points here. You can start at 0. Pi over 6 will give you 5. And cosine of pi over 6, you can go to all these measures right here and put them in your calculator. And they'll give you decimal approximations. So just to show you what I mean. So y equals, we'll change that to 5 cosine, whoops, clear that out. 5 cosine theta. Second table. All right, now what we want is our theta. We're going to change this. So we go second table set. We want to start at 0. And then we want to count by pi over 6. Okay, and we'll just go second pi divided by 6. Whoops, I forgot to hit enter. Okay, enter. This is where I want my pi over 6. Second graph for your table. And so here's these values. 5 radical 3 over 2 is approximately 4.301. So you can see here's just around 4.3, and I'm right there at that angle. 2.5, right about there. And that would be pi over 3. Oops, I lost my calculator. I did pi over 4. I did all the lines just to get enough points to plot. And there's my circle. So again, you can use your 30, 60, 90 right triangles here to plot all those values. No problem. But I'm going to have the same circle. Here's my center, 2.5, 5 halves, 2.5, with my radius of 5 halves. And here's my circle. So again, I graphed it. And I make my curve. Again, make sure you hit zoom 7 and then square up your window. All right, if we want to convert 4x minus 5y plus 3 equals 0 to polar equation, all right, we got to get rid of the x and the y's. So we're going to put r cosine theta in for x, r sine theta in for y. Now, in order to have a polar equation, as you saw on my graphic calculator, when I hit the y equals button, it says r equals. So we have to solve this for r. So I'm going to factor the r out of both terms, and then literally divide this binomial over to the negative 3, and there's my equation. Okay, just to bring the calculator back into play, as I was mentioning previously, but my calculator fell behind the PowerPoint, so I wanted to come back and show you what I mean. So here I hit the zoom 7. I'll show you my window. You can see that this is 2 pi, and we're counting by pi over 2 for the x scale. My y's are -4 to 4, but everything here is in your trig version in radians. But it's not a circle when I hit graph. To turn it into the circle, just hit zoom and hit the square button, choice number 5. And then it squares up the window, so it's not a rectangular shape, but actually a square shape. So it adjusts the x and y's, and now it looks like your circle over here that I have on the screen.